Hello again, and thanks for joining us on Astronomy Daily. I'm your host, Andrew Dunkley. Coming up, we're going to look at the cause of the runaway greenhouse effect on Venus. They think they've nailed down what's happened. We're also going to look at an out-of-this-world egg experiment and some new minerals discovered on Earth never seen before. That's all coming up on Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
Once again, we're joined by our reporter, Hallie. Hi, Hallie. How are you?
Hi, Andrew. I hear you choked at golf again yesterday.
Oh, that's not nice. I wouldn't call it a choke. I was playing rather well and just lost my concentration. There's a big difference, you know.
Yeah, whatever you reckon.
Oh, you are in a cheeky mood. Well, that's enough. Let's get the news.
Astronomers are becoming increasingly concerned about the future of the night sky as new images show significant trails left by a massive communications satellite against clear and dark patches of sky. In September, AST SpaceMobile launched the first satellite of a new constellation into orbit, paving the way for a system of cell phone towers in space. This prototype, known as BlueWalker 3, carries the largest antenna of any commercial communications satellite to date. And sadly, it's now one of the brightest things in the sky, outshining even some of the most famous stars. A committee of the International Astronomical Union has denounced the launch, warning of the dangers posed by this satellite and its successors. According to Piero Benvenuti, an astrophysicist at the University of Padova in Italy and an IAU representative, BlueWalker 3 is a big shift in the constellation satellite issue and should give us all reason to pause. Although these projects may improve cell and internet access across the globe, the IAU urges everyone, particularly the companies launching such satellites and the Regulatory Federal Communications Commission, to consider the collateral damage to the night sky. AST SpaceMobile responded by saying, "We are eager to use the newest technologies and strategies to mitigate possible impacts to astronomy. We are actively working with industry experts on the latest innovations, including next-generation anti-reflective materials." AST SpaceMobile is already in talks with IAU representatives about the issue, according to an IAU statement. When NASA's James Webb Space Telescope launched on Christmas Day, 2021, it began a new era of space observation for astronomers. Now it's set to follow up on data from a citizen science project called Backyard Worlds, Planet 9, that hunts for cool, dim objects in our stellar neighborhood. These objects could be planets, or other kinds of objects like brown dwarfs, a mysterious class of not-quite stars. Volunteers with Backyard Worlds have found a number of candidate objects that need a closer look, and the telescope will begin scanning the sky for them in the coming months, hopefully revealing new data and new information about the diversity of objects in the universe near Earth. Dan Castledon, a citizen scientist and a co-investigator on an upcoming JWST observing campaign looking for brown dwarfs, says, "They're really hard to find. It's the needle in the haystack problem, which is so much fun." The project is encouraging other citizen scientists to get involved. There are 8 billion of us now. Well, 8 billion of you humans, I should say. The UN says when the population peaks around the year 2100, there'll be 11 billion human souls. Our population growth is colliding with the natural world on a greater scale than ever, and we're losing between 200 and 2,000 species each year, according to the World Wildlife Federation. An engineer from the UK says that one way to mitigate the damage from the clash between humanity and nature is to create more habitat, and one way to do that might be by building Terran ecosystem preserves on Mars. Paul L. Smith is a civil engineer in the Faculty of Engineering at the University of Bristol, revealed how we could build a nature preserve on Mars that would act as an extraterrestrial nature reserve. The ETNR would act as both a psychological refuge and botanical garden. Smith talks about placing nature preserves in subterranean lava tubes, which would provide UV protection and other benefits. While there are a lot of questions and logistical problems to solve, Smith believes it's possible, but even if we can't do it on Mars, perhaps the idea will at least make more people realize we have to keep nature alive on Earth. And that's the news, Andrew.
Okay, food for thought. Thanks, Hallie. We'll catch up with you near the end. Now to Venus, one of our nearest neighbours in the solar system, and a place that is incredibly hostile due to its runaway greenhouse effect. But how did it all happen? Why is Venus in the situation it's in now when it used to actually be livable? In fact, they think at one stage Venus, Earth and Mars were all livable planets. Now it's just us. So what happened to Venus? Well, it looks like they've figured it out, and it may have something to do with volcanoes, as my colleague from Space Nuts, Professor Fred Watson, explains.
The prevailing theory is that Venus might not always have been the hellish place that it is now, and that something triggered a runaway greenhouse effect. And of course, Earth could be on the brink of one of those as well. There are tipping points in the climate. I think we're certainly not near the tipping point for a total runaway greenhouse effect like you get with Venus, but these tipping points are real. And if you think Venus has got a runaway greenhouse effect, and we all do, then you will be looking for something that triggered that actually pushed a climate which we believe was quite benign, as you've said, in the early history of Venus, into the regime where it is now, where the surface temperature is roughly 460 degrees Celsius. And the pressures, if I remember rightly, it's 90 atmospheres. It's nearly 100 times the pressure of the surface on Earth. So very, very different, and lots of carbon dioxide in the atmosphere. So what has happened is that scientists who are based at NASA and elsewhere, in fact, one of them is at the Goddard Institute for Space Studies, which is in New York. That's a NASA institute. A gentleman by the name of Dr. Michael Way, he refers to something called large igneous provinces.
Oh.
And large igneous provinces are apparently the result of volcanic activity that may have lasted between hundreds and thousands of centuries, not years, centuries, and delivered colossal amounts of magmatic material to the surface of the planet. Now, there's evidence that the Earth has gone through phases like this. And the suggestion is that some of them may have caused mass extinctions. But the really interesting aspect of this research that we're talking about from Dr. Way and others is that on Venus, about 80% of the surface is covered by these lava fields, large areas of solidified volcanic rock. One of the comments that Dr. Way made was, well, we're not yet sure how often the events that created these fields occurred. We should be able to narrow it down by studying Earth's own history. And they go on to say that in the last 500 million years, and that's about how long multicelled organisms have been alive on our planet, there have been about 5 of these major mass extinction events that got rid of about half of the animal life on the planet. And the studies that have been made, including this one, suggest that most of these events actually were caused or perhaps even made worse by the eruptions that produce these large igneous provinces, these fields of lava. So the comments that's made is that in the case of the Earth, the climatic disruptions that those extinction events and those volcanic periods of volcanic activity, the climate disruptions weren't enough to trigger a runaway greenhouse phenomenon. But clearly it was on Venus, because that's what we see today, the effect of a runaway greenhouse, with this surface temperature in the 400s of degrees Celsius.
Professor Fred Watson, astronomer at large and my co-presenter on Space Nuts. You can hear the full story on the latest edition of Space Nuts, out very soon, if not already.
The Astronomy Daily Podcast
with Andrew Dunkley.
Now, you've probably heard of the egg drop experiment. This is something that's done in high schools all over the world, where students are challenged to build some kind of structure that will prevent a raw egg from breaking when dropped from a significant height. Well, here's an egg drop experiment that goes way, way, way out of this world. And it involved a former NASA engineer who took the thing to a whole new level, the stratosphere, to be precise. And just like you'd expect with a former NASA engineer, Mark Rober and his team constantly designed and redesigned a rig that would take an egg into space and drop it back to Earth. And they had some help from the people at JPL, and even a parachute made out of the same material used on Mars rovers. And just like the best NASA projects, years of trials, failures, and scrubbed launches are necessary to make a project successful. And after starting the project 3 years ago, a new video has just been published to show their triumph. And it had over 17 million views in a few days when it was posted. Both the egg and the rocket came back to Earth fully intact. You can watch the video on YouTube. Finally, a meteorite expert from the University of Alberta was part of a team of researchers that discovered at least 2 new minerals never before seen on Earth. Chris Hurd is a professor at the Department of Earth and Atmospheric Sciences and curator of the University of Alberta's meteorite collection. And he was contracted a couple of years ago about trying to classify a 15-ton meteorite found in Somalia, the 9th largest meteorite ever found. And he said, in the course of doing the classification, describing this new rock for science, I came across some inclusions, some potentially different, interesting materials inside the meteorite. What we've now discovered is there are at least 2 minerals in the meteorite from Somalia that have never been discovered before. Most people in my profession, he went on saying, will go through their career and not even find 1 new mineral. Here, just by virtue of examining this meteorite, we came across 2. So what are they? The new minerals have been named, and I really am going to murder this, ellalite and elkinstantonite. And there's potentially a third one being examined. Now, this particular meteorite is quite dense, almost double the density of any rock on Earth, which makes it quite interesting. And it is also quite magnetic. And Hurd believes more minerals could be found if researchers can obtain more samples. But researchers say the meteorite appears to have been moved to China and its future is unknown. What a pity. All right, if you want to chase up those stories, jump on our new URL, astronomydaily.io. You can chase them up there, or you can subscribe to the newsletter and get it delivered to your inbox every day. And don't forget, as I mentioned earlier, the latest edition of Space Nuts, episode 333, is out now for you to enjoy with Professor Fred Watson, looking at those volcanoes on Mars and strange filaments in our universe that are very, very difficult to explain. Hallie, anything before we wrap it up for another day?
Yes. What does a baby computer call its father?
I don't know. What does a baby computer call its father?
Data. Ha!
Yeah, keep trying, Hallie. See ya.
But I've got another one.
No, you haven't.
Hey, no fair.
Until next time, this is Andrew Dunkley for Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.